Hi, my name is Abhishek, and I'm with Tom, our head of engineering. We, Inloop Studio, are in the business of building digital brains for companies, mostly in the realm of private equity firms and their portfolio companies. And lots of people ask, so what is digital brain and who needs it? When I'm in the meetings, usually people will be like, so what is this thing called digital brain? Intentionally or unintentionally, if you are using any AI tools today, you are building your digital brain. If you've been using GPT Cloud or any tools in the company today, you are giving away a lot of context that belongs to you, either in personal capacity or in your organization, into these services. And what we do is help people build their pristine layer of context, which is what the digital brain is all about. In today's world, every problem solving involves using AI in some way. And if you are using AI to solve any of your problems, you are telling a lot about you and your organization to these services. And that's where your brain is implicitly getting created today. And what we do is we help companies take these decisions intentionally, own the digital context, the pristine layer of context of their company. So that's what we do. And that's what we offer to our clients. And that's what digital brain building essentially means. You will see this in our call later, where we can show you how it feels like, how does it look like. But at this moment, why people come to us is because they want to solve a problem. Well, the problem solving for last 30 years have been about understanding the problem, documenting it, and then solutioning it. So if you hired somebody from a consulting organization like the McKinsey's, like the Bain of the world, and you gave a problem to them to solve, they would go and first do a bunch of interviews, bunch of discoveries, call people into a meeting and ask questions, deep questions, and then somehow create report, document all of that. And then uh, the end of it would be solutioning, where they would come and either give you PowerPoint decks or a spreadsheet and financial model, or sometimes we go into like implementation of systems that support the process. Now, what we're seeing is there's a big shift in how the organizational problem solving happens. You've got to work with human plus AI together. And in this process, there is discovery that's led by human plus AI, which is part of the Inloop process. Then you create the digital brain, and then that informs the agents that further builds the solutions for you. And that's where the agents take over the world and start to work on the context that you have given to it. And that's how we're going to solve the hard problems in your organization with human plus AI collaboration. So, what does that feel like? What does it look like? We don't have a lot of time to go in details about how this works, but a deep discovery on Inloop platform looks somewhat like this. You have a bunch of spaces in 1 week or sometimes in multiple weeks. You run through a process where there's discovery, deep discovery, design, validate. And these are activities either done by human or by AI. This is the interface that is given to the facilitators, or what we call our forward deployed operators. And they use this platform to orchestrate the entire deep discovery process. And this is specifically how it looks when they're building it. And that builds a digital brain, which has a way to govern, access, and evolve with a improvement loop. And then when it comes to implementation, that's where this today's call is about Inloop Runway, which is one of the things in our toolkit, which allows people to expedite their implementations faster. So Inloop Runway is the platform that allows you to codify your business processes, and it becomes the business software, the business system that your team uses. So this is how the Runway application looks like. It is a piece of software that is just given away to our clients who go through the entire process and our forward deployed operators, the people who are actually running this process, they're building lots of mockups or sometimes the actual implementation on this platform. So what is it? It's a base sort of application template, but very opinionated, and it has been designed for the AI native era. So what you see there is this would look like any internal business system, but it's very agentic in its foundation. So starting with a human AI org chart, which clearly describes the users and the agents in your system, in your business. And then, as you would assume in any application, you would need different modules from your CRM to your NDA and contract management to payroll to some opinionated systems over here, which our clients like to use. So that's what Inloop Runway is all about. It's a way for people to accelerate their implementations of business processes, right? I have Tom with me who's our head of engineering, and he is going to explain what's beneath the surface. I want Tom, why don't we talk about what is Runway from an engineering standpoint?
Oh, absolutely. To start off, Runway was a late point in our design in the sense that as Inloop, we're really good at facilitating, we're really good at consulting. We're here to kind of color in the people's problems, to understand where the landscape is with their problems and their kind of domain problem sets. Because of this, we realized that although we aren't ones to give the biggest solutions, there are always a set of primitives that you need to operate whenever you run a business. So Runway comes with a lot of the basic primitives that a business needs. On top of a CRM kind of asset management, the one thing that we're pretty proud of is the foundations to make all of that. And that kind of brings us to FOSM. So FOSM is a state machine construct where we have a public gem to do FOSM apps. It's essentially finite object state machines. It's an evolution on regular state machines on top of state charts. The idea is everything that you can define in a business, you can probably define in a state machine.
Yeah, so perfect. Why don't we talk about a little bit more about why finite object state machines?
Finite object state machines is a little bit special, but there's nothing too new in the idea of state machines. So there was this recent study on Meter where if you give an AI tasks, like a task list with the right kind of states, it will treat that as a state machine and it will write better software. It's one of the biggest research areas where if you're familiar with Anthropic Claude, they transition from to-dos to tasks, and tasks are really state machines behind the scenes. A lot of the efforts on software factories is hoping to move that paradigm shift towards state machines. And with state machines, you can write more durable, more safe, and more correct software. You can also, with that kind of constraint away, where you don't worry about bugs, AI eventually creates really beautiful software.
Yeah, so then state machine essentially becomes an important primitive for that to happen. And I think what we've done is we have made this core of that open source as well for the community. And we're relying quite a lot on Ruby as the domain specific language to express it. And once you express your state machine and your business process in form of this DSL, the domain specific language, the AI just knows how to then maintain and grow it from there. So what's the connection between what I'm seeing on the screen, which is this, and the end user experience that people usually see on a platform like this? So what happens? What are these things on the left? And what's their connection with all this?
Yeah. So the things that you see on the side in this runway demo are what we call FOSM objects. So every kind of element you see here in your business workload can be broken down into finite object state machines. Thus, you have a set amount of objects to establish and create foundational work for your business. The perfect and the beautiful thing about FOSM is that a lot of the engineering principles that we've incorporated just from our experience when working with Ruby is the idea of lifecycle, the idea of transition logs. Those are things that when at scale you would consider, but no one kind of treats this for the small and medium like private equity. This is really critical software where we cannot afford to have anything to fail. Finite object state machines not only give us kind of the structure for the AI to do really beautiful software, there's also a lot of observability that we incorporated in the library. So,
So the non-technical people who are listening to this, when we give the code base and all of our implementations are on Inloop Runway, they all benefit from these simple primitives that is designed for AI agents to maintain. So it's software written from ground up with best practices, which is for regulated industries, by the way. And what on your screen are lots of interesting primitives already built into the platform. And this is your source code. And it's a guardrail given to the coding agents. By the way, that's all also is our open source work. And we allow people to take this piece of software and then build their application on top of it. And this is how it's different from you just going into cloud code and starting to wipe code a system from scratch. Is that correct, Tom?
yes, that's absolutely correct. The idea is we software is a complex beast. We don't want to put users into that software dev cycle in the same sense that we wanted to migrate away and let business users focus on business. So the FOSM is one of the biggest foundations we need to make this all work. And then how we work it with agents, how do we make it collaborate, work together, is a lot of the skills that we worked with software engineering in general. It has a lot of experience both in the consulting side and the software engineering side to hopefully marry that together to get all of the objects that you need for your studio.
Perfect. So what that means is when people engage with Inloop Studio and you've involved us in architecting your systems and your business processes, people get Inloop Runway's implementation that looks somewhat like this, right? The biggest question that we get asked is when we move away from a client organization after we are done with all this implementation, how does the improvement cycle works? If we give this software piece of software away for the client team to manage, what are the different things that make it easier for them to maintain this and build upon it? We do have built-in feedback loop, which is an automatic, which is really learning from the usage internally. It monitors the user behavior on the platform and how people are using your application. And then it creates a bunch of tickets, and then that tickets, you can choose whether to do it in-house or assign it to an in-loop team. And that's where the idea of a software factory comes in. So you get a code base, you get a system that has self-improving loop, and then you get an ability to ask experts to help you out. So yeah, so what am I seeing on the screen? You have a user who has submitted a request to improve this piece of software, and then there's a note for Inloop Studio team, and then there's this thing called Inloop Estimate. What is that?
What's on the screen is a simple object where you see the estimation between humans and agents. Here we have a concept of agent hours. So agent hours come from a lot of the ideas that we had for a serverless agency. This is a way for us to do both an estimate on the agent and the human hours, as well as automations on our side, where the engineers don't really need to worry about this too much. So this is mostly automated on their side, and then we give that receipt back to the client.
All right. So what you're saying is we've got a process where we can estimate a piece of task and figure out what humans do and what AI does to accomplish the goals of that request that the client has made over here. How does it flow through the entire workflow on our engineering side? So what happens when you have a request like this? Let's change a button. When it comes in, somebody's got to estimate this. And you said, oh, we have a way for us to estimate this. What is it? How does that work? And at this moment, I would love to talk about how we do what we do. We do use Pi as a coding agent internally. We've built some extensions that allows us to just makes it easier for us to do estimations and actual measurement of this work. So why don't we talk about a little bit about what is happening after the request like this lands on an engineer's dashboard?
In that case, I'll show a very quick, somewhat crude demo of how all of this works together. So let me share my screen. Before we start the demo, there's a lot of the concepts that we introduce, especially with Pi and Pi extensions. Pi is just a coding harness. It's a coding harness where you can do quite a lot of fun things. You'll see YC startups, especially like the SI browser, other similar YC companies, YC26, use Pi as their kind of main harness to do their basically their entire startup. It's a way to have a plug and play version, tests ideas, tests essentially test a harness for our use case. On top of that, we do have an open source front facing for PyLedger. So PyLedger is just a Pi extension. So behind the scenes, it's a lot of the automation that comes that's typical with serverless compute. So I have a very quick demo on what could be a typical family office. Normally, a family office would have a CRM, they would have some context, they would have some initiatives, but they have quality checks, they have quality demands where they just want to make this a little bit more inviting to work with. On Runway, it's quite easy to take that up. You can just create a feedback where, let's say, we have a UX issue, and this UX issue we want to add some 3D elements to the strategic initiatives on our Runway app, because why not? So let's write that out. So we want better animations. All right, have better animations with 3D, 3 elements for our strategic initiatives. This feedback will be a little bit kind of sparse in the sense that there's not much detail that's given to the user or the engineer in that case. That's
That's
where
what happens. That's what usually happens, right? And people don't have, they just give a quick one liner on what the improvement could be. And these are internal staff members of the family office operations.
I've submitted the feedback. Before this kind of pipes down to us where we get it, this has to be assigned. In any Runway implementation, there's always the admin dashboard. So this is kind of the crux of what makes Runway. So all of the FOSM details, all of the niceties that you get with like a true technical software, all of that's been pre-built. So this inbox is a triage area. You have an option to assign it to your in-house team where it's someone part of your core team that they can do the work for you. Otherwise, you can assign it to the Inloop team where we'll get the response, the email to do this to hopefully assign an engineer to help settle your task.
And this is a collaboration between the team that runs Runway in their environment and app Inloop.studio, which is our own infrastructure where our engineers look at it, right?
Yeah, absolutely. Runway is the tenancy that the clients have. It's their special software. It's all their kind of secret sauce lives there. It's not visible to us. There's only one secure bridge, which is what you're seeing here, the bridge to send feedback to us and then to sandbox it out to idealize what the feature might be, what the fix might be, to triage and send back to the client. Now that we're in the client Runway, we go back to the feedback. The feedback has now a new in-loop estimate. So we can see the in-loop estimate detail where here it has my summary where I've gone into detail on why this is quoted this way. The client can agree or decline and then have some extra emails, some extra kind of meetings to help flush it out. Now that this is agreed, so right now you can see the progress where we've started it. We've started the kickoff of this task. This task is now in progress because they sent the agreement, and then now we're here to give evidence, to deliver, to ship, to give evidence of our work. We have a spot where we'll deliver the effort both on the agent side and the human side. So imagine this is the client's code base where they would own this code base, they would own everything to it. with the protocol that we have embedded to speak between us and the runway, behind the scenes, there should be a autopilot. One of our innovations is having agent to investigate in the background to understand the scope of the work and just do some of the work behind the scenes.
So this is even before somebody has actually started working on this. I just want to say, stint over non-technical audience, somebody who's watching this, what really has happened here is a piece of the task, which was a request to improve the system that has gone in. As a client, you've got an estimation from an engineer with a complete split of what's a human effort and what's an AI effort. And while you're still working on while the process is still going on, an engineer hasn't yet touched the code base, there is the pre-work that has already started.
Maybe yeah. The pre-work will be the starting foundations for the engineer to understand the scope and catch up with what kind of the agent has made in its taste to tackle the fix. So as an engineer, I have a kind of a separate responsibility to make sure that once I have the pre-work done, I have the due diligence that no data is being lost. And FOSM helps a lot with that. So FOSM, we never lose data with FOSM. So here I have a terminal where I kind of just do my work on in Pi exactly. So this is a ledger status bar that comes with PyLedger. It will count the human and the agent hours as we do the work. So as an engineer, I want to add these 3D elements and animations to the initiatives page. So how I would prompt it would be on top of the harness that I have behind the scenes. It would be our client wants to have a bit of animations and love for the strategic initiatives page in the Runway app. The typical stack that I'm aiming for is to incorporate motion or frame of motion, and 3GS for the 3D animations. So here I would describe the type of animation that I want for this family office. I won't spend too much time with the prompt here, but this would be a little bit of a sneak peek of how a typical engineer would at least start out their prompts before they go into deeper agent discovery. So I'll press enter. Behind the scenes, you'll eventually see these numbers move. So these numbers move when the agent and the human interact more with the application. So
Yeah, and what's happening here is this is a live demonstration of how a one-liner vague requirement then turns into the actual prompt that an engineer writes. This is where the human judgment comes in, right? This is where the taste comes in. Yeah, and then now Pi is doing its job, the harness is doing its job, and the background, you're capturing the effort that the agent is spending and the humans is spending.
yeah. So in the agent's empty, there is a lot of elements that we incorporate to make sure that the agent doesn't stray off. For the non-technical people, the agent's MD is the rule book and a part of the playbook to make sure that the agent doesn't stray off too far and knows what our idealized rationales are for creating software. So here you see a lot of the topics where we want to constrain how to work with FOSM, what kind of branding elements, design tokens we need to take care of, a lot of the scope disciplines that we incorporate with the app. And hopefully this will translate into better modeling, both on the human side and on the AI side. So the human just needs to worry about the big strategic concept of fulfilling the task. Here, the agent just needs to just follow the user's instructions and then know the magic behind the scenes. So here is our document on the FOSM rationale, the reason why it exists, all the patterns that it incorporates for FOSM, so that when the agent works on a task, it knows what FOSM is, it knows how to write it. It's like they lived a life with FOSM, escaped to an island, and then lived happily ever after. Yeah, that's the sense that we want. So as you can see in the status bar, Ledger popping up some numbers. Here is the agent numbers just going up. So the agent number it calculates the speed of the token, the speed of the AI, how fast it generates. as well as the time it takes to run a tool. Things like idle time, things like downtime, where sometimes providers like Anthropic would have some downtime with their API. So we don't count that. We don't count those idle times. Those are very sensitive times that we shouldn't build the client for. Yeah. And it has finished the task. Yeah. Here it's a little bit simple, but we might have overestimated. But we have a working implementation. So here is all of the code that the AI has made. We can see a kind of a diff view of what it has tried to incorporate. And then, yeah, the next step is the due diligence on the engineer side, which is just to, for now, create a new PR and push it up. Here we let the engineer first do the push towards GitHub so that it solidifies the code. And then they do the end-to-end test. So hopefully this end-to-end test, once they do the testing, they have the design correct, they got the feel that they want, then they hopefully merge to the code to the client's runway, and then the client will see that fix almost immediately. I guess if we're counting time, it has been just maybe 10 minutes. 10 minutes between the time the client has sent the feedback and then the engineer has noticed the feedback and iterated on the idea. In this terminal app, I have a kind of a very convenient method to keep track of the differences and kind of the pull requests up there. So this has created a pull request onto the code. So yes. And then behind the scenes, it goes through its due diligence, test the code if it's okay, statically test the code, and review the code if there's any issues.
And just on that page, you are also the AI native code review that's happening on the pull request. What is it that the code review is doing? I think it's worth talking about that as well.
Yeah. So in each of our runway, we have an option to set up an AI code review. AI code review here is basically a partner. So a coding partner where it looks at the Ruby code and sees if the differences make sense. So if we're touching really sensitive code, we need to be triple sure that we aren't breaking anything. The AI review is basically an advisor in that sense, where it would nitpick on the hard stuff in the code, where the main agent and even sometimes the human could possibly miss. So this is our kind of frontline defense to make sure that whatever code that kind of gets out is correct code, it's running code, it's not breaking code. Yeah.
Yeah, and this is the way we ensure that software is reliable and there are enough checks in place to ensure that, number one, a good quality harness in the form of all the best practices on Finite Object State Machine, and then the code base also follows these process automatically anyway.
Yeah. So with that in mind, we don't want to wait too long since this is just a demo, but you will typically see if there is an error between any of these checks, the human engineer will take notice and then fix any issues. Since this is all okay, let's just squash and merge it up. And then hopefully just see the results on the page. Okay. With that in mind, we've technically done the work. So let's actually switch back here. Here you get PyLedger doing its thing. So we don't count idle time. If idle time doesn't have an outcome or doesn't have an output, that idle time isn't counted. Here we have a small grace time to check. If the human's active, we know when they're active. If they're not active, we show this pop-up. So this pop-up is for them to check if they're still there or if they're finished. Here, we just finished. So we'll finish there. And then we will now print the receipt. So this receipt is what we send as the evidence for their work to the client, as well as to us as managing Inloop Studio.
What's important about this process is it's not the numbers that you see on the screen because these are all demo numbers, but it's the clear separation of what a client is paying for. You're paying for a human judgment and the combined work with the agent.
Yeah. So hours aside, certain elements that we don't bill. So stalls where there are generation kind of hiccups that happens with inference providers. So if you're using either Codex, Claude, or even open source providers, they all have very small quirks that take a bit of time that don't actually do anything. So we don't bill that to the client at all.
Quickly recap, what we've done is we've got In the Runway code base, somebody is submitting the request for improvement. That request has traveled from the your own Runway instance to Inloop Studio's system. There, an engineer has estimated it, has given their first rough sort of idea of what would it take to implement it. Then the client, on the other hand, have approved the estimation. As soon as the estimation is approved, the work has already started by our system because our agents have started preparing the code base for that work to be done and accomplished. And then you as an engineer, Tom, whenever you get a chance, you start to work on it using PyLedger, which is helping you keep track of the effort that AI is doing and what human is doing. The this is the receipt of the work that was done by human and AI to accomplish this task. So amazing. Are we done?
Yeah.
Is the task done? Okay, awesome.
Yes. So hopefully this will on the client's side, it will pop up on their pipeline. So here I think it's all good. So let's check back on to the app. There we go. Yep. Let's see what the AI has thought up of. So here is the animation now. So this is probably a lot more than what the client would have expected. Some nice animations where you can hover over these pills. There's some nice spring animations. You can see the 3D office in the background. It's a nice element to help Runway look a little bit better.
That's amazing, isn't it? You've got, on one hand, a simple interface that you started with, and a simple one-liner feedback then goes into the entire process, the software factory, to then make the improvement. And then what's on the screen is a full dashboard.
Yeah. You typically see with client runways where a good handful of them, they need a better user experience. This is it's not a kind of issue with our app. Our app is flexible in the sense that they can create anything that they wish to. All it needs is a bit of work on their side, or just send a feedback to the Inloop Studio team, and then we will give our flavor, our approach to solving that problem.
Perfect. So hopefully anybody who's watching this understands what does it take to get a platform like this and the entire software factory process where you have an end-to-end life cycle of how your platform evolves as the business requirements evolves. So Tom, if there is somebody on the client side who takes up a role as a CTO or a fractional CTO or a one person engineer who is doing all of this themselves, what does it take for them to take this code base and then do the exact same thing that we've done over here?
They can do almost the exact same thing that we've done here. Say, for instance, a fractional CTO has direct access to the code. They can just clone the code down and then work with their favorite harness, Codex, Claude, or Pi, and then hopefully just ship a feature out to their liking. The really big difference is the essence in harness. As you've seen in kind of my work, I have slightly custom harnesses to make sure my life is easier and things get done quicker. Likewise, with other engineers, they would have their own harness, they would have their own kind of workflows, how they do sub agents, etc. The sky's the limit. There's really no limitation for anyone on their side. It could be someone else other than a CTO. It could be someone that's not too adept with engineering, can push out very small fixes quite easily. So the effort here is almost frictionless.
Awesome. So there's no vendor lock-in. Any engineer with their own set of tools. Tom prefers Pi. I sometimes prefer open code. And we have other engineers who prefer something else. And all of them can work together with their favorite tools.
Yeah.
Awesome. Man, this is good. I hope people who are watching this get a complete idea about how the full end-to-end cycle of product development actually happens on Runway as a platform. Yeah, anybody who's listening to this, if you have any questions, we would love to hear more from you. You can contact us at help@inloop.studio. And me and Tom would be happy to answer any questions you might have. Awesome. Thank you so much, Tom.
Likewise. Thank you for having me.